So what we're going to learn about today is how we can find all the roots. Now suppose that we have z to the power of 2 equals 4. Question is, what are the solutions for z here? Just off the top of your head. 2.
-2.
Right. Easy.
Sounds so easy. Oh my God.
Easy. Z squared equals 4, so take the square root of both sides. And you remember it's plus or minus. So it's 2 or minus 2. Drop the mic. Are we happy with that?
Partially.
So if we have a square root, how many solutions do we expect?
2.
2. Alright, what about the next one?
5.
Omega cubed. What are the solutions to this?
5. -5.
Simply cube root both sides.
-5. Yeah. That's negative.
We get 5
It's only 5.
or negative 5.
Does -5 work?
I don't know, try it.
I don't think it works.
You don't think or you know?
I know.
It doesn't work because that would give us
Negative 125.
negative 125.
About half.
So the rule is if it's a cube root, you're only going to get one root. Are we okay with that, boys?
No.
Alright, are there any questions?
No, it's got to be
Or are we
3.
done?
It's got to be 3.
Alright, what about if we had alpha to the power of 4 equals, and we're going to say $16.
Yes. So easy.
What would the solutions be for this?
2.
Oh, yeah, that's great. Yeah. Just the rest whites you Craig.
Little Hinchcliffe, you're over there. Oh, it's his.
To look after. Can I eat it now?
No, I'll eat it.
And there's a stash. Okay.
Alright. So we take the fourth root, we get 16. So we discovered that the answers are going to be 2 or minus 2. So what's the rule here?
Is that alpha in the second row?
Yeah, second one would just be alpha.
What's the rule with roots? If it's a even, how many roots do we get?
It's got 2.
And if it's odd,
1.
1. Is that the rule?
Nah.
Probably not, unless you're not a specialist, but we are specialists. So what we discover is that when we're dealing with a square root, we're probably expecting 2 roots. When we're dealing with a cube root, we're just expecting 1, or could there be 3? And if we're dealing with a higher root, so 4, we're expecting 4 roots. But how do we find them? That's the question.
They complex.
Yes. Okay. So I'll leave this up. Let's have a look let's look at from a geometrical perspective. If we're trying to find the roots to a solution or problem, what we're expecting is that if we have the real axis here, this is 0. We know that plotting it out, the cube root of z to the 4, this is going to be 2 over here, and we're going to get negative 2 over here. So this is z to the power of 2 equals 4. So z equals minus 2 or 2. How are they positioned on the plane? Equally, because they're 180 degrees or pi apart. Now let's put a conjecture forward. What might we expect? We've got the real axis here. For omega, we've got 0 there. We're going to get 5. How many roots are there?
3.
3. How would we space them apart? If there were 2 roots, we divided 2 pi by 2,
120.
120. So what we're going to discover is that our roots are going to be here, here, and here. They're all going to be equally spaced. 2 pi on 3 radians apart.
Did you work that out? It's obvious.
Sorry?
Is that obvious? Because
That's,
so I might divide by 3.
that's 4 pi on 3.
By 4?
Oh, sorry. I'm bamboozling myself. The distance from there to there is 4 pi on 3. This is 2 pi on 3. And that's 2 pi on 3. Oh, okay?
Yes.
Now the question is, how would we do this mathematically and get it right every single time? What is the way in which we could work this out? And the way we think about this is we go back to our knowledge on the unit circle. So, geometrically, this is what we're expecting it to look like. Geometrically, this is what we're going to expect it to look like. I'm going to show you how you can do this using polar form to calculate it exactly. Are we ready? All right, let's take this back because this is year 11 sort of work. We're better than that. What we're first going to do is we are going to write this in polar form. If we were going to write z squared, that's fine. Before, how do we write that in polar form? Modulus of 4, cis argument of 0. Now, I'm going to add something in. This comes from solving trig equations. 0 plus 2k pi for every trip around the circle, which is a multiple of k, where k is going to be an integer multiple. The symbol for integer is... Jeez, I can't believe I forgot. It's not n, it's the other one. Sorry? Z, yes, sorry. I can't believe I forgot that. Okay, any positive integer multiple. So if we sort this out, it's going to be 4 cis 2k pi.
Is obviously the main frame.
Okay, next step, apply the square root to both sides. Z is going to be the square root of 4. Which can be rewritten as a fraction, so to the power of half. Use de Moivre's theorem. This is going to be 2 cis 2k pi over 2. The 2's cancel. K pi. Next question is, how many solutions are we expecting? 2, because it's a square root. Oh, sorry, it's a square. So we're expecting 2. How many values of k are we going to sub in?
2.
So k is going to be 0 and 1. When we do this, it will be 2 cis 0 pi or 2 cis pi. Hence, z is going to be, what was it? 2 or negative 2. We okay with that? Does it make sense?
Why does k equal 0 or 1?
You just pick two values of k that are contiguous. 0, 1, you could do 2, 3, 4, 5. You could even do 7, 8, or 8 and 9. You just pick two values that are next to each other. Because the reason we pick k is we're trying to spin around the circle, sort of.
Yep.
Is that alright? Okay, now if we're looking at this example over here, again, this is year 10, year 11. Oh, spelled year wrong. That's perfectly fine, but we're better than that because we're specialists. We are going to solve this by saying omega r cubed, notice I'm not saying w, it's omega, is going to be 125 for its modulus, cis 0. But we know it's not just going to be 0, it's going to be 2k pi. Where k is going to be an integer multiple. Next, apply the cube root. We cool with that? And then, cube root of 125, sure, it's just 5. That's our first solution. Cis 2k pi 3. Simply put this in our calculator. We're going to find that it's 5 cis 0 or 5 cis 2 pi over 3 or 5 cis, and it's going to be 4 pi over 3. Hence, do we have a solution? If we put these in our calculators. You guys want to put it in your calculators?
So, yeah,
Rather than cis, what symbol should you use on these ones?
the degrees thingy.
The phasor symbol.
How do you spell phasor?
PH. That's phasor.
Like a gun, baby.
Like a PH.
Not a taser.
P-H-A-S-C-R.
5 phase 0.
Like a gun.
5 phase 2 pi on 3. 5 phase
Like the
4 pi on 3.
Like no.
Remember, you can't use the phasor symbol in the internal or external, but we use it on our calculator.
This stuff.
Shush.
What do you want me to do?
I want you to be quiet.
At work time. I don't have any work.
You just sit there quiet.
Yeah, right.
You don't look happy then, Rose. Happy what? Are you radius? Is that all? I don't know the angle of the one. It just looks like bad, right?
Boom. So we've got 3 solutions there. 1, 2, 3. Look at the last 2. They look similar to each other, but their signs are different, aren't they?
Yeah.
Because
I don't know.
they both go out the same horizontal amount, but their vertical amounts are opposite one another.
Oh. You idiot.
That always won't happen, right?
Oh yeah, it will always happen like that.
It will always happen like that.
There's always symmetry. In this case, there's 3 axes of symmetry there.
Oh yeah.
Another way you can do it, rather than doing that, you can use the phasor symbol. And if you know that there's going to be 3 of these guys, then you can just type in, take the first root, which is just the first plain root, get one of the dumb calculators, type in the square root or the cube root. It'll tell you the first one, which would be 5, or if it's negative 125, it will be minus 5. And then you just find the phase by dividing 2 pi by how many solutions you're expecting.
Would there be questions where it's just all imaginary?
Yeah, of course. Yeah.
Oh crap.
We can find the nth root of unity on an imaginary number if we want.
What's
In which case they don't necessarily, the first one's not on the real axis, it will be rotated, so point out there somewhere. That would be a good internal question or a good external exam question.
Is that difficult?
No, they're not.
Oh, okay. That's easy marks.
It's just formula.
Okay.
Now, where we go with this, now that's exciting, but that's not for now.
Triangles.
Pentagons, octagons, yeah.
Holy
Are we okay with that explanation?
Yeah, I like to.
Can we
Do
do
we know why we're getting all of these solutions?
No.
Can we do the alpha to the power of 4 equals 16?
Alpha to the power of 4 equals 16. Yeah, but it's geometrically wrong. This would be your imaginary axis. This would be your real axis. Do you agree? And they'll have arrows on them. If it's z to the power of 4 or z to the power of 4 equals 16, the first root is just going to be 2, correct?
Yes.
And you know that, how many roots are you expecting?
4.
4. So they're going to be spaced 1, 2, 3, 4. 1, 2, 3, 4. Their modulus are all equal in length. So at here is going to be -2, up here is going to be 2i, and down here is going to be negative 2i. Is that cool? Rule 5, draw out a star, and if you go round and connect all the heads of the vectors together, you'll get a pentagon. It's pretty interesting stuff, really. Is that cool? Any questions?
Questions?
Do we go on to the textbook?
Yeah. All right, in a bit I'll show you the next bit.